Hi everyone, this lesson is for Algebra 2 Honors students. This is chapter 7-8. Today we are covering 7.10 rational functions and fractional equations. So some of these may have extraneous solutions. So this is day 3. Let's get started. Our learning targets today are pretty simple. Given a fractional equation, be able to solve it. So we're going to start off with a rational equation. And so what you see is 1/4 plus 1/5 equals 1 over t. Your objective is to solve for the variable, which is t. And there's multiple ways of solving this problem. One of the ways that you would solve this is to get a common denominator, add the two quantities together, and then divide, or cross multiply and then divide. So let's get started with that. If I wanted to combine these two terms right here, they're both fractions. They have different denominators. I'm going to multiply this side by 5 over 5 because I'm not going to change the equation. And by multiplying by 1, you're not changing the equation. I'm going to multiply this term by 4 over 4. And in doing that, I'm going to end up getting 5 times 1, which is 5 over 20, plus 1 times 4, which is 4 over 20. And so that's going to be 9 over 20. And so that equals 1 over t. And what I could do for this problem is simply just cross multiply, and then I'm going to have 9 times t is equal to 20 times 1. So t is going to equal 20 divided by 9. Some restrictions for this are just to make sure that your denominator is not 0. Additionally, so you know that the value here, t, cannot equal 0, which means that if I were to plug in 20 for t, 20 over 9, that is not 0. So this would be my solution. Put your answer in solution sets because it is a solution. Okay. For this problem here, I'm going to do this one a little bit differently than the last problem. Instead of combining two terms and then cross multiplying, what I'm going to do for this one is get a common denominator and then cross multiply. So what happens here is a common denominator is often the product of the values on the denominator. So this right now I just have 2. I have x and I have 3. So a combination of the 2 times 3 times x is 6x. So I'm going to try to make my denominators all equal 6x. And in doing that, what ends up happening is for this term here, I'm going to multiply this by 3x over 3x. Because when I multiply this term times that, I'm going to get 6x on the denominator. For this problem, this term here, I'm going to multiply this term by 6 over 6. Because then that would give me 6x on the denominator. For this term here, the 1/3, I'm going to multiply this term by 2x over 2x. And on the right, I'm going to multiply this term by 6 over 6. So I'm multiplying by 1 across the board. I'm not changing the problem anywhere. And I'm going to end up getting a common denominator. So I've got 3x times 1, which is 3x, plus 2 times 6, which is 12. And I've got 6x on the denominator here, 6x. This is 6x. Equals 2x times 1 is 2x over 6x. And again, I've got plus 18 over 6x. Now, combining these two, I'm going to get 6x on the denominator, and I get on the numerator 3x plus 12. On the right-hand side, I'm going to get 2x plus 18, and this is all over 6x as well. What ends up happening when you cross multiply is that you end up getting 6x times 3x plus 12 is equal to 6x, this one right here, times 2x plus 18. Now, you definitely do not want to distribute that 6x through because realistically, I can just divide by 6x on both sides, and that loses that value here. And therefore, I end up with 3x plus 12 is equal to 2x plus 18. What that means is that this step, these two steps right here, realistically are not required because if you know if you know that when you cross multiply, your 6x's or your denominators are going to cancel, right here, this is what I would do, is cross that out, because what this 3x plus 12 is basically the numerator after you have gotten the denominators to equal the same terms. So now I just have to simplify. I'm going to subtract 2x. I get x. 2x from 3x, I get x. And I'm going to subtract 12. I get x equals 6. Now, this is my answer. Your answer is going to be put in solution set. So you would write x equals the solution set of 6. You want to make sure, however, that going back in the beginning right here, that you want to make sure that the denominator cannot equal 0. So 2, that's not a problem here. This one though, x is 6, x is fine. Right here, x is 6 again. So you're basically plugging in your solution, which is 6, put that in solution sets. You're plugging in that solution back into the question to make sure your denominator does not equal 0. Because if your denominator does equal 0, then that's not allowed, and that's what we end up getting is called an extraneous solution, which is basically an answer that when you plug into the equation does not work, makes a non-solution. So solving rational equations. So for this problem here, again, I want to get the common denominator. Now, again, multiple ways of solving this equation. You could combine the left two terms and then cross multiply. Or you can just try to get all the terms on the denominator the same and then cross out the denominator, because you know that when you cross multiply, they're going to cancel. So this, I'm just going to factor this real quick to make sure that, so we have x, we've got a -4, and we have a +3. So this actually has both of my other denominators. And again, like I said before, often when you are adding fractions that have different denominators, the common denominator is going to be a product, meaning you're going to multiply the products together like we did on that last problem. So in this case, I'm going to multiply this term by x plus 3 over x plus 3. And this term I'm going to multiply by x minus 4 over x minus 4. Because what happens here is, again, you're going to end up with 2x times x minus 4 plus x times x plus 3 is equal to 2. And all of these are underneath this umbrella here. That's the x minus 4 times the x plus 3. But what's going to actually happen is, again, the x minus 4 and then the x plus 3. What ends up happening is when I cross multiply, my denominators are going to cancel. So realistically, what I only need to do is, and you can only cancel those denominators if they're exactly the same. And so now I'm just going to set my numerators equal to each other. So I get distribute 2x squared minus 8x plus x squared plus 3x, and then that equals 2. And I do notice that this is quadratic, which means I do want to set my equation equal to 0. So I get 2x squared plus 1x squared, which is 3x squared. I have -8 plus 3, which makes -5x. And then I've got this 2, which I'm going to bring over to the other side of the equation. And I'm going to factor and see if I can factor. I could use the discriminant to see if it works, but I'm just going to check first. So 3x and then x. And to get a negative sign here is one's going to be plus, one's going to be minus. I'm just going to try 2 and 1. And then when you check, 3x times -2 is -6x. 1 times x is positive x. So that actually makes -5x, which is what we wanted. So that means that we have the right factorization here. So now what I'm going to do is I'm going to split this up and I'm going to set both sides equal to 0. So I have x minus 2 equals 0, x equals 2. I have 3x plus 1 equals 0, 3x equals -1, x equals -1/3. I'm going to check my answers up here because I want to make sure your restrictions are that x cannot equal 4, and you also know that x cannot equal -3, neither of which we got as a solution. So therefore, your answer is going to be x equals, and it's going to be negative 1/3, comma 2. Put your answers in solution sets. Perfect. For this problem here, and let's see, I'm going to factor this first. So that's x times x plus 2. Okay, so my common denominator is going to be a product of x times x plus 2, which on the left here I have x plus 2, which means I'm going to multiply this one by x over x. This one is missing the x plus 2, so I'm going to multiply this term by x plus 2 over x plus 2. And this term already has that denominator, so I don't have to change it. For my numerator, I'm going to multiply through x times that, so I get 3x squared, plus, now I'm going to distribute, I get 6x plus 12, and that's equal to 12. And what it looks like now is that all my denominators are going to cancel because now they're all the same. I'm going to set this equal to 0 because it is quadratic, but when I move the 12 over, that is going to cancel both of those 12s. So I have 3x squared plus 6x. Now what I'm going to do is factor out a 3. I get x, oh, and an x. Let's do that. Let's take out a 3 and an x. And hold on. So we have 3x. We're going to factor out that. And we have x plus 2 left. And that equals 0. So I'm going to set both of these equal to 0. 3x equals 0. I've got x plus 2 equals 0. So here, x is equal to negative 2. Here, I'm going to divide by 3. 0 divided by any number is 0. So I have x is equal to 0. And with that, my two solutions are going to be x equals 0 and negative 2. However, I do want to make sure that both of these answers are going to work when I plug them back in. So I should do that before I box this all up. So let's check. Going back up to the top, I'm going to erase this so that I can see clearly on the denominator. And it does look like if I were to plug in 0 for that value here, it would be a 0 on my denominator. Additionally, for this problem, we also see this. See, you were setting this equal to 0. You're setting this equal to 0. We know that x cannot equal 0, but I got a 0 as an answer. We also know that if I solve this, I'm going to get x equals negative 2, which is also an answer. But they can't equal they cannot equal 0 on the denominator. So what that means is this, is that in this case, in this very special case, both of my answers are what we call extraneous. That means that I got them as an answer, but they're not a solution, meaning they're an answer, check. But when you plug it back into the equation, doesn't work. So it's undefined, therefore they're no solution. So what you would do then is you would kick them out of the little bracket house here because neither one of these is a solution. And so you would either have an empty set with 0 and negative 2 outside, or you could put a no solution here with 0 and negative 2 outside. You do need to show that these are the values that x cannot equal. Those are your what we call extraneous solutions. So by doing that, we have solved this and we've showed our extraneous solutions because x cannot equal 0 and x cannot equal negative 2. For this problem, we are going to get a common denominator, but first, because I see that this is over 1, so that's going to need a lot of help. This one, let's factor this. This becomes x and x. This, to get a positive here and a negative here, means they both have to be negative, and it looks like it's going to be 5 and 2. So this one in the middle actually needs both of those terms, okay? It needs the x squared minus 7x, and then plus 10. It needs all of that. And this one, though, only needs the x minus 2. So x minus 2. And then again, you still have to multiply top and bottom by x squared minus 7x plus 10. And what that's going to do is it's going to allow me to cancel out my denominator and set my numerators equal to each other. So I'm going to write this out. I have 3 plus this value here, which is 2 times x squared minus 7x plus 10. is equal to x minus 4 times x minus 2. And what that's going to do is I just have to simplify now that my denominator is gone and they're all exactly the same. We are going to get 3 plus 2x squared minus 14x plus 20. And that's just me distributing that 2. And then on the right, I'm going to get x squared minus 2x minus 4x, which is minus 6x. And then negative 4 times negative 2 is plus 8. Again, this is quadratic, so I am going to set this equal to 0, and I'm going to move all my values that are on the right over to the left-hand side and set that equal to 0. So one at a time, I've got 2x squared and then a minus 1x squared, and that's going to give me x squared. So those are done. I've got a negative 14x, and then when I move this negative 6 over to the left, that's going to become positive 6x. So we have negative 14 plus 6, which is negative 8x. So those values are gone. I have 3 plus 20, which is 23. And then when I move this positive 8 over to the left-hand side, it's going to become a negative. And I'm going to borrow. I end up getting 15. And therefore positive 15, so that's plus 15. So now I just have to solve, and this is going to factor to be x and x minus 3 and minus 5, so that when I split this up, I'm going to get x minus 5 equals 0. I get x equals 5. X minus 3 equals 0. X equals 3. And so therefore my two solutions are going to be 3 and 5. However, please make note that because this is a factored form already, we already know from this right here that x, right here, that we know that when we set that equal to 0, we know that x cannot equal, so we know x cannot equal 2. We also know that x cannot equal 5. In which case, you'll notice that I have a 5 here that I got as an answer. So 5 is actually going to be then kicked out of my solution set because it's not an answer. It's an answer, but it's not a solution. But you do need to show that you got it as an answer. You show that it's extraneous. So 3 is the only happy person, favored child, in the solution set, and 5 here has been kicked out of the house. So 5 is outside of the solution set, and here we go. We've got x equals 3 as my solution. 5 is an answer, but we call 5 extraneous, and extraneous, E-O-U-S, extraneous. Okay. For this last problem here, I am going to factor this set. So, and that's not a difference of 2 squares. Factoring out an x is going to give me x minus 1. I have an x minus 1 here already, so this term on the right just needs an x. However, this term in the middle does need both because it has a 1 on the denominator. So it does need to be multiplied by x squared minus x as a quantity. So this is going to be x squared minus x also. Okay, so denominators are all the same. I've got 2 is equal to 1 times x squared minus x, and then plus 2x. Again, it's quadratic. I'm going to set everything equal to 0. So all I have to do is move this 2 to the other side. So I have x squared, and then negative x plus 2 is 1x. So plus x minus 2, and that equals 0. I'm going to factor. So I have 0 equals, let's see if this factors, 2. I got an x times x. To get a negative sign, 1's plus, 1's minus. This is a positive 1. So that's going to be 2, and then subtract 1. And just a heads up, right? Look at the top. Look up here. You already know that x cannot equal 0. And you already know that x cannot equal 1. So hopefully we get something else besides those two numbers. So when I split this up, set each equal to 0. So x minus 1 equals 0, x equals 1, extraneous. X plus 2 equals 0, so x is equal to negative 2. So I did get two solutions, two answers, and checking them, -2 is completely fine, right? -2 squared is 4. 4 minus -2 is 6. That's fine. -2 minus 1 is -3. Completely fine. But 1, we know that if we plugged 1 in the denominator or here or there, we would get 0. And so 1 is not going to work. So 1 becomes our extraneous solution. -2 is our solution. So we have -2. And then 1 outside is an extraneous solution. 2 answers, 1 solution, 1 extraneous solution. All right? All right, cool. Given a fractional equation, be able to solve it? Check. We also checked for extraneous solutions, so we are in good shape. You have homework, which is page 381. And you do have an exit ticket, which is just a 1-question exit ticket, and each individual needs to submit their own answer. But you will have time, obviously, this is such a short day, that you'll have time to work with your breakout rooms and help each other on that problem. So thanks so much for watching, and enjoy the rest of your day.